Hello everyone. So for those who find my video without going through my website, let me introduce myself. My name is Gilles Urtubise and my scientific name, or as a self-taught and multidisciplinary and inventor, is Gilles Lauzon Urtubise, and I am the owner and the founder of the first human multi-intelligence.com. This video is it's about what happens when an object of telluric or other nature and of a dimension that varies between 1 meters and 1 kilometers in length, like that of an asteroid, has an irregular shape when it collides on the surface of at depth with the stars or the sun. So what happened is it begins to melt until it is transformed into atoms, and then these atoms rise to the surface of the sun, because apart from the atoms of the natural chemical element hydrogen, which have the smallest volume, all the other atoms of the other 93 natural chemical elements, they have all a volume that is greater than that of the hydrogen atoms. So, and like I told in the video before, when a star is born, it's always from celestial sphere, which she's dying. Then and when its star is born as a star that produces radiation, it is all the time like a millisecond pulsar, which is the ancestor of our sun and which led to the formation of our solar system. Or when a star is born as a result of surface bursting and then exploding from its mother, which is a black celestial sphere of a superior volume, into a nova, supernova, or hypernova. This had the consequences of giving a birth to it in our millisecond pulsar, which is the ancestor of all stars that are born. On the other hand, if its size is one of the largest millisecond pulsar of the largest millisecond stars, in this case they are named by all the other scientists magnetar, and this term suits me, even if the magnetar have, apart from their superior stars, the same characteristic as the millisecond pulsar. Subsequently, the ancestor of all stars, which is a millisecond pulsar, which varies in size between small and gigantic, and in the case of the gigantic one, they are called magnetar, and it is found and after it's born, it is found to decrease in rotation speed, because when the pulsar millisecond born, they have the same speed of the black celestial sphere, so the speed which is 716 rotation per second. But after they are born, they used to their speed going lower, but little bit and by a long time. And then when they born as a pulsar millisecond, so after a long time, their speed going low to 1 rotation per second, which as this time they are called pulsar. And after a certain times, the pulsar becomes a star, a blue star, so a star like the color of blue. But after to decrease of speed, this color changed to white. After they changed to yellow, after this to orange, to red, after to brown, and finally to black. But when the star becomes black, at a certain times they stop completely to turn on itself, and they die gravitationally. So then, so that it is. So yeah. So. And like I said just before, what happens when an object of telluric or other nature and a dimension of 1 meters to 1 kilometers, like asteroid has an irregular shape, when it collides on the surface or at depth with a star or sun, whatever, if it's born or a long time after they're born, this matter, it begins to melt until it is transformed into atoms, and then these atoms rise to the surface, to the star or the sun. And after some. And when those atoms becomes to the surface, when so a process get action, and this process is breaking all the strong and weak interaction bonds at the same time, which serve to hold all species of elementary particles together of one atoms at the time. And when all the links of strong interaction and others that are weaker are broken, this has the consequences of producing a violent separation and a violent burst of all the elementary particles in such a way as the violently move them away from each other and from the surface of the star or the sun, while producing at the same time the number of level of radiation energy which is equal to the number of the species of elementary particle released. And among them, level of radiation energy that varies between strong and other that are weaker, and more precisely of two set of atoms. And the ones that follow is the set of the hydrogen atoms. So in the case of the first set of radiant energy, it comes from the hydrogen atom, which has one elementary particle, which is that of its electron, and three species of elementary particle which are used to form its proton, because what has long been recognized is that the hydrogen atom is made up of a single electron and a single proton, which is made up of two U quarks and one D quark. This has the consequences of proving that it is composed of at least 4 species of elementary particles. And when the atom is found to undergo a thermal shock, which is of sufficient violence, this has the consequences of breaking at the same time all its strong interaction links and others that are weaker. And when the 3 strong interaction bonds break, it as the consequences of producing a violent separation and a violent push of the three species of elementary particle released, so as to move them away violently from each other and from the surface of the star or the sun, while producing at the same time three strong levels of radiant energy. And at the same time to break at least one weak interaction link, and when the weak interaction link breaks, this has the consequences of producing a violent separation of the electron from the atoms and a violent dearth of the electron from the other three species of elementary particle released, in such a way as to violently move it away from the other elementary particle released and from the surface of the star or the sun, while at the same time producing a level of radiation which is weaker than the other. On the other hand, particles physicists have so far invented 61 species of elementary particle, which seems to me to be relatively acceptable and believable for me. Nevertheless, it will be necessary in the future to validate or invalidate some of these 61 species of elementary particle, so that currently, and in the case of the hydrogen atom, it is necessary to take into account a quantity of additional elementary particle which can reach up to a total of 61 species of elementary particle. Otherwise, photosphere of the sun or other star. So the photosphere is another part of the star that produces visible light, among other things. It is more or less extensive, less than 0.1% of the radius for the dwarf star, and or a few hundred kilometers or a few tenths of percent of the star radius from the larger ones, which will give them a fuzzy outline unlike the sun with sharp edges. But about this, I'm not sure if it's right, if the photosphere is a part of the sun. I think for me it's out of the sun, so it's a little part which is just outside of the sun, because the temperature of the sun is too high. So for me to have that temperature at its surface doesn't make so much sense for me. Or doesn't make enough sense for me. Then the light produced there contains all the information about the temperature, surface gravity, and chemical composition of the star. For the sun, the photosphere is about 40 kilometers thick. Its average temperature is 6,000 Kelvin. It also to define the effective temperature, which for the sun is 5,781 Kelvin. The structure of the sun beyond the photosphere is commonly known as the solar atmosphere. It has three main areas. So the chromosphere, the solar corona, and the heliosphere. But I think they have four. I think the photosphere is a part of the atmosphere. So we'll see later. But for me, the photosphere is a part of the atmosphere of the sun or any other star. So what about the chromosphere? The chromosphere itself is about 2,000 kilometers thick. Its temperature gradually increases with altitude, reaching a maximum of 100,000 Kelvin at its summit. So, and solar corona, the transition zone between the chromosphere and the solar corona is the seat of a rapid rise in temperature which can approach 1 million Kelvin. This rise is related to a phase transition during which helium becomes totally ionized under the effect of very high temperature. The transition zone does not have a clearly defined elevation. Roughly, it's from a halo over engine the chromosphere in the appearance of speckles and filament. It is the seat of the chaotic and permanent movement. The solar corona is composed of 73% of hydrogen and 25% of helium. Temperature are in the million of degrees. So I'm not agree with those percentage, but I'm gonna explain it why further. So, and yeah, so, and the heliosphere beginning about 20 solar rays, so it's equal to 0.1 AU, so astronomic unit. So which it means AU, which is mean astronomic unit. From the center of the sun, the heliosphere extends to the far reaches of the solar system. So yeah, so here, this is the solar corona, and the small parts, the little part, the little line of pink, it's the chromosphere. So okay, so that's enough for this video. So yeah, that's what happened. So this is where the radiations come from. It's not come from the nuclear fusion, because these things does not exist, and the man cannot reproduce it. So, and why? Because it doesn't exist. And if it exists, that's pretty tragic, because that's made the universe. Because after sometimes certain periods of time of the universe, all the stars transform the hydrogen atoms in helium atoms, and after if these things happen after certain times, they have no more chance for life. So the life could not, because if all hydrogen atoms disappear, there's no more chance for life for any condition, then the start could life appear. So this is no sense. The fusion, the nuclear fusion could not exist and does not exist. And I put much more price in the future video. So okay, so thank you. Have a nice day. Goodbye.